I'm Ennemcien. Now, radioactivity, as I said earlier, posting, is a first order reaction and it takes a long time to finish the process. Nearly infinite time, lakhs and lakhs of years. So we define two time factors to study radioactivity. One is half-life. Half-life is the time required to disintegrate half the amount of parent nucleus. So, disintegration formula is n equals n0 e raised to minus lambda t. When t equals t half-life, n, the remaining atoms must reduce to half the initial value, that is n0 by 2. So just to introduce these values here, in the place of n, you put n0 by 2 equals n0 into e raised to minus lambda into t half. From this is e raised to minus lambda t half means 1 by e raised to plus lambda t half. That means you can equate these two denominator of e raised to lambda t equals 2. Just to express this in logarithmic form, so log 2 to the base e, that is called a natural logarithm, equals index lambda t half. So lambda t half equals natural logarithm of 2. Logarithm of 2 is 0.6931. Therefore, t half equals 0.693 by lambda. So half-life is inversely proportional to lambda, disintegration constant, and is independent of the amount. There is no factor showing the quantity of the or number of atoms in the sample. So that means time required for 4 kilogram to 2 kilogram and 2 kilogram to 1 kilogram and 1 kilogram to 0.5 kilogram, etc. Same time period is required. So half-life is independent of the amount present. Next point is mean life. Suppose there are 1,000 radioactive atoms in a sample. There will be one atom which begins the activity. So what is the life of that atom? Definitely it is 0. Birth and death take place instantaneously at the same time. So its life is 0. There will be one nucleus that is integrated at the end of the process. That's the 1,000th atom. Time taken by these 1,000 nuclei to disintegrate completely is a lot of time. That is theoretically infinite time. So there is a particular atom that begins the process and there is a particular atom that disintegrates at the end of the process. That means the life of that atom is infinity. Life of the first atom is 0. So that means life period of lifespan of different atoms in the sample will be different. So we want to define an average life for a radioactive atom because it varies from 0 to infinity theoretically. It is in this context that we define mean life. Derivation is not required for your standard. So mean life is represented by the letter tau and it is 1 by lambda, reciprocal of disintegration constant. Half-life is 0.693 by lambda. Mean life is 1 by lambda. Just you plot a graph between n number of atoms remaining for disintegration or number of parent atoms and time. The graph is like this. At t equals 0, number of atoms present is n0. When t equals t half, number reduces to n0 by 2. n0 by 2 means n0 by 2 raised to 1. Then time required to disintegrate this to its half. That means n0 by 2 by 2 or n0 by 4. That is twice the half-life. n0 by 4 means n0 by 2 square. Still, to disintegrate half of this, that means to become n0 by 4 by 2 or n0 by 8, that requires 3 half-lives. n0 by 8 is n0 by 2 raised to 3. So after one half-life, number remaining is n0 by 2 raised to 1. After two half-lives, number remaining is n0 by 2 raised to 2. After three halves, number remaining is n0 by 2 raised to 3. That means after n half-lives, number remaining for disintegration equals n0 by 2 raised to n. That's it. Then, one more point. Suppose there be n1 active atoms present. These n1 atoms are called parent atoms. And let its disintegration constant be lambda 1. When a parent atom disintegrates, it is converted to a daughter nucleus. This daughter nucleus is also radioactive. It will disintegrate to form a granddaughter, and so on. So let lambda 2 be the disintegration constant of the daughter. As the number of parents decreases, number of daughter increases, because parent is becoming daughter. But since the daughter is also disintegrating to produce granddaughter, number of atoms of daughter also decreases. Now there can be an equilibrium state when the rate of disintegration of the parent becomes equal to the rate of disintegration of the daughter. That is, dn by dt of the parent equals dn by dt of the daughter. This is a kind of equilibrium, dynamic equilibrium. The decay of the parent can be equal to the growth of daughter. Then there's a transient state. dn by dt is equal to lambda n. So rate of disintegration, rate of decay of parent is n1 lambda 1, because dn by dt is n lambda. Rate of growth of daughter is n2 lambda 2. So when these two rates are equal, we say that the system is in equilibrium. Daughter, parent, equilibrium. Then we can write n1 lambda 1 equals n2 lambda 2. We will see the rest in the coming postings. Thank you.